Good morning. Now let's take a look on problem 20 from OpenStax College Physics under the topic motion equations for constant acceleration in one dimension. An Olympic class sprinter starts a race with an acceleration of 4.50 meters per second squared. What is her speed 2.40 seconds later? Sketch the graph of her position versus time for this period. Now, again, for constant acceleration motion in one dimension, I normally write all the equations that I know. There are, I think, only four that will be relevant, which is in this case, I'll write V or the V final is equal to V initial plus AT acceleration. This is time. Note that this is for constant acceleration motion. I also write here S. S here is just the change. Some books write this as x minus xo or things like that. S here corresponds to displacement. VOT plus 1 half AT squared. And I also write things like 2AS is equal to velocity final squared minus velocity initial squared. V here corresponds to final velocity. And or you can put F there if you want to. Maybe I'll put there F. And lastly, I'm writing. Yeah, I think that's it. We can just solve all of the problems using these three formulas. Okay, so let us see. In this case, we're asked for what? What is her speed 2.40 seconds later? So part A is clearly asking for the what? The A. Problem A asking for the V, okay? Speed. V here and speed are essentially the same. It's just that it's the magnitude for this case, this is just a straight line motion. The magnitude of the velocity is just the speed. So we have here Vf is equal to Vo plus At. Now, to find the velocity after 2.40 seconds, meaning t there is 2.40 seconds clearly, so we'll have here like 4.50 meter per second squared multiplied by time, which is 2.40 seconds. Okay, now that's good already. However, we don't know VO yet, but if you carefully analyze the situation, note that the runner, the sprinter, must be starting from rest, right? And then speeds up, accelerating until he reaches a speed of we don't know yet, but during that t equal to 2.40 seconds, he must be starting from rest, okay? And able to attain a certain speed, Vf. So let's have here 0, and therefore, based on that, we can solve for Vf, right? So Vf is just equal to, meaning this the velocity after 2.40 seconds, it will just be equal to 4.50 multiplied by 2.40, and that's equal to 10.8 meter per second. So meaning after that, so starting from rest, the sprinter is able to reach this speed for only around 2.40 seconds. Now, how about part B? Sketch a graph of her position versus time. Okay, so meaning position versus time. So let us try to sketch the graph. Okay, here let me have here the time on the abscissa or the x-axis, and y is position. Okay, this is position. Let me call that x, and no, let me call this as a position, and in our x-axis this is time. Okay, so if we start from, of course, we could at time 0, where will be your runner be or your sprinter? Of course, at what? At position 0 also. Now at time, oh, at time, shall we say 0.5 seconds? Let us label points. By the way, the displacement, what the displacement formula is this one. S is equal to VOT plus 1 half AT squared. And note that S here is just the change in position. Okay, so we could just write it here as what? S, instead of S, I can write x minus xo if I want to. VO is just 0, so I'll have 1 half. A is I mean, I'll just write it there. VOT plus 1 half AT squared. Note here that x minus xo is the change in position. So at time 0, I can use this equation to solve for what? To solve for my this position with respect to time. So I think here I can just have here like x is equal to xo, and VOT is 0. VO is 0, so I'll have 1 half of A. A is 4.50, so what is 1 half of that? zero point 0.5 times 4.50. I could have 2.25, so I can have here like plus 2.25 t squared. Okay, and xo, by the way, we're assuming, of course, it's 0. Okay, we are assuming xo is 0, meaning at the start it starts from x equal to 0. So the position x will just be 2.25 t squared. Now if you know already algebra, and then you have gone through graphing a what, this will essentially be a, this is a parabola, right? It's a parabola opening upward. So if you graph that, it may look like this during that time interval, but we could really compute, for example, at time what? A time, a time equal to, let me have a table here. The position, and this is the time. When time equal to 0, the position is 0. The runner is at position 0. At time equal to zero point 0.5, shall we say? Let me solve that. 2.25 times zero point 0.5 squared. Okay, that's 0.56, 0.5625. At time equal to, shall we say, 1, it's equal to 2.25. And at time equal to, let's go to directly to, what's this? 2.40. I'm just drawing a rough sketch anyway. So when t is 2. I mean, oh no. When t is 2.40, so 2.40 squared times 2.25 times 2.25, that's 12.96. So 12.96 there. So this one, this is 12.96 here, roughly. During that time interval, the runner is able to what? To run around 13 meters during that time interval of 2.40 seconds. So if we plot the rest of the points, perhaps here, things like that, it will form a what? If you somehow plot that, it will form a parabola that can be traced and look like this one. Half of the parabola only, of course, because time is positive. I hope you aren't confused with this one. If you're a bit confused as of now, just try to take a look on some other practice problems. Hopefully, you will learn through those problems. Thank you.